All these things are discussed in the last class. Open circuit, closed circuit, a meaning of a short circuit. And what do you mean by series connection, parallel connection? And we have differentiated series circuits and parallel circuits. And these things are discussed. All right. And we have solved figure number 1, 2, 3. And I have asked you to solve the figure number 5. And out of 6, 4 problems are solved. To solve figure number 4 and figure number 6, some more concepts are needed. That will be discussed now. To solve figure number 4, the following concept is needed. It is shown in next slide. Here, a simple circuit, 2 resistors along with the wire is connected between the nodes A and B. Then it is a kind of parallel or a series combination of the resistors. But because of this wire, usually wire does have a zero resistance. The resistance of this wire is a 0. And we have discussed in a parallel circuit, we do find different paths for the flow of the current. When current enters at this node, it has 2 options. Either it can move in this path or it can move through this path. All right. So I repeat, when current enters at this node, it has 2 options. The incoming current can go through this path or else through this path. All right. So resistance of this path is 0. The nature of the current is always it finds the low resistance path for its flow. Compared to these 2 paths, it has a 2 ohms of resistance. It has a 0 ohm of resistance. In this path, current is disturbed. There is an opposition for the flow of the current because of this 2 ohm. The nature of the current is it always finds the low resistance path. For that reason, the incoming current at this point, will completely goes with this path. As a result, the current in this path will be 0. So if the current in this path is 0 means so that the presence of this resistor can be neglected. Whether it is present in the circuit or not present in the circuit, it doesn't matter. There is no impact of a 2 ohm resistor in the circuit because the current available before the node will go after the node through this path. 0 current will flow through 2 ohm resistor. Because of that reason, this resistor can be neglected. The technical word for this discussion is the resistor 2 ohm is bypassed. the 2 ohm resistor in the circuit is bypassed, or else it is shorted. I hope the concept is clear. So could you please send me your response in chat box? If the concept is clear means we'll go further. I wanted to say the concept of bypassing. What do you mean by bypassing? When registers are bypassed, that registers can be neglected. It doesn't have any effect on the circuit. Whether it is present or not present, there is no impact of the register on that circuit. Am I clear? So you can take any circuit here other than that. I will write here the different circuits. Here 3 circuits are connected. It is what, okay, I will make use of a whiteboard. All right. So consider the voltage source, the series resistance, three parallel resistors are connected here. Okay. So take any random values. It is R1, R2, R3, R4. All right. So it is what, assume a 5 volt. This is a circuit. This is a simple circuit. For that circuit, simply one wire is added between the nodes A and B. Okay, solve for this network. If this is a question, then how to solve it? Because of this short, because of this short, R4 can be neglected. As a result, whether it is present in the network or not, it doesn't matter. All right. Okay. R4 is neglected. Then what about R3? Again, it is shorted. So that even R3 can also be neglected. So that whether it is present in the network or not, it doesn't matter. All right. Then again, what about R3, R2, the resistor R2? Again, it is shorted. Again, that resistor is bypassed here because the two nodes of the resistors are shorted here. Technically, it can called as a bypassed. So if that is the case means, so R2 resistor can also be neglected. So that what could be the final answer? This is equals to a voltage source with only single resistor. Okay, the remaining 3 resistors R2, R3 and R4, they are neglected because they are bypassed. I hope the concept is clear. All right. So keeping that concept in our mind, then can you solve figure number 4? Can you solve figure number 4? All right. So 250 ohm and 470 ohm, they are in series. So these two resistors can be converted into a single resistor. So that it can be R1 plus R2. All right. Then So keep A as it is. So it is 940 ohm. So what is this answer? What is R1 plus R2? What is this R1 plus R2? Is this a 720 ohm? 600, 650, 720. All right. Now, can we apply a bypass concept here? Can you neglect a 720 ohm resistor because it is shorted using this wire? It can be neglected so that A, B will be as it is. So A will be as it is. What is equivalent circuit between the nodes A and B? It is what? Only 940 ohm. Am I clear? Give a response in chat box. All right. So to solve the figure number 6, star and delta connection concept is needed. Then can you tell me in figure number 6, can you observe any series and parallel connections of the resistors? Clearly observe the figure number 6. Then tell me which resistors they are in parallel or whether they are in series. Do you find any series or a parallel combination? If yes means tell me in a text box. Do you find any series or a parallel combinations of a resistors? Keep the point A and B in your mind. Those two things should not be disturbed. Do you find any series or parallel combination of a resistors in figure number 6? Two 20 and 330 are in series. Okay. 230 ohm and 330 ohm resistors will be in series if 470 ohm is not connected to this point. What do you mean by series connection? There should be a single path for the flow of the current. When current enters at this node, it will be having two options. Either it can go along with 470 or 330 ohm. It does have two options at this node. So that 270 and 330 ohm resistors, they cannot be in series because of this 470 is interconnected at this point. I hope Annapurna, you have understood why 220 and 330 are not in series. Anybody? Do you find any series or parallel combinations of any resistors? Point A and point B should be considered here. So The result is the none of the resistors are they are in series or in parallel. Okay, it is a concept of star and delta connections of the resistors that will be discussed in upcoming days. So now, right now, we don't solve a figure number 6 problem. Keep that point in your mind. Once we do complete star delta concepts, it can be solved. All right. Okay. Keeping that points in your mind. So all we have discussed a few things. Keeping all those things in our mind, we will solve one simple problem here. Determine the following. Determine the following quantities for each of the two circuits shown below. There are two circuits A and B. For circuit A, calculate equivalent resistance, current from the power supply, the current through each resistance, the voltage drop across each resistor, then power dissipated in each resistor. Okay, so I do solve problem A. Then after that discussion, hopefully you will solve the figure number B. Okay, so to solve this, we are in need of one concept, that is Ohm's law. What do you mean by Ohm's law? You have studied it. I do repeat here. Ohm's law states that the current through a conductor between the 2 points is directly proportional to the voltage across the 2 points. I hope you have studied it. Consider any conductor or any wire. Then current flowing through that wire is directly proportional to applied voltage. That is called as a Ohm's law. So you can see here a notation E is used. Either you can use E or V, one another say. There is no problem. When the conductor is considered, this current, the flow of this current is directly proportional to a voltage that is written here. When current is flowing in an conductor, that is directly proportional to applied voltage. Then this proportionally directly proportional symbol can be removed by a resistance R. This is called as a Ohm's law. All right. Next is what? When applied voltage and currents are known, then how to calculate resistor using this formula. When R is equals to E by I, where E or V one another same. Don't confuse. Whether we can use V or E, they are one another same. When E and I are known, then R can be calculated using this formula. All right. Next is using Ohm's law, a current can be calculated if the applied voltage and resistance of that paths are known using I is equals to E by R. However, if current in the path and the resistance of that path are known, then applied voltage can be calculated using V or E is equals to I into R. These are the formulas. It looks simple. They are simple formulas. They are needed throughout the network theory subject. Application of these formulas in a proper manner will give a correct answers for the given problems. All right. Now consider the given problem. We solve the first point A, that is first point, the equivalent resistance. How to find out equivalent resistance of this given network? While finding equivalent resistance, you should not consider anything other than the resistors. Okay, so consider only 20, 30 and 50. Then they are connected in series. They are connected in series. Am I right? Yeah, because there is only one path for the flow of the current. So what is answer for the first question? The equivalent resistance that I have calculated here. The resistance in series add up. All these three resistance can be replaced by the single resistor, that is 100 ohms. Yes, right answer, Vijay Lakshmi. Okay, all right. Then second point, current from the a power supply. We have discussed what is current from, what is Ohm's law? What is Ohm's law? E is equals to I into R. Here R is what? R equivalent, or else simply not needed. You just keep that point in your mind. R is nothing but a resistor here. Then how to calculate this total current in the network? Now it becomes R equals I equals to, sorry, E equals to I into R equivalent. All right. Now E is known, that is 125. R equivalent we have calculated as 100 ohms. Then what could be the answer of current I? 1.25, right? Then you should not forget to mention its unit. It is amperes, A. At the end of the every calculation, don't forget to write an ampere. It should be capital A. Right. That is I have done here. So the total current is determined by the voltage of the power supply and the equivalent resistance of the circuit. Have you calculated? That gives the total current is equals to total voltage divided by total resistance or equivalent resistance. Total voltage is 125 divided by 100, that is 1.25. All right. Then current through each resistance. What could be the answer? What is the answer for point number 3? Current through 20 ohm resistor, 30 ohm resistor and 50 ohm resistor. 1.25. I'm getting answers as a 1.2 amperes. What is the reason? We have studied in a series circuit, flow of current in all the elements will be same. We have calculated total current in the network. What is that? We have calculated total current in the network, that is I total, that is equals to 1.25 amperes. Is this the same current flowing in this way? Is this the same current? Yes, it is same. It is also same. It enters this point and leaves this point. Enters, leaves. Okay, so this meeting will end. We do have last 10 minutes. We'll see. I do complete within that 10 minutes. Okay. Okay. The total current we have calculated 1.25. That the same current will be flowing through 50 ohm, 30 ohm and 20 ohm. So that answer for the third question is what? 1.25. Okay, so total current equals to I1, I2, I3. This is the case only if the circuit resistors, they are connected in a series. Okay, then what about fourth one? Then voltage drop across each resistors. Then what is voltage? Voltage here in this case is equals to I into R. In series circuit, in a series circuit, the voltage will be different. In series circuit, voltage will be different. Voltage across 20 is different. Voltage across 30 and voltage across 50, all are different, because in a series circuits current will be same but voltage will be different. So that what is that I have calculated here. What is voltage drop across 20 ohm? So I1 into R1. So what is I1? I1 is nothing but I total, that is why I calculated 1.25 into 20, it is 25 volt. Similarly, calculate voltage drop across 30 ohm, that is I2 into R2. Okay, 37.5. Good. Then can you calculate the third voltage drop? Can you calculate? Okay, good. 62.5. All right. Then what about the power dissipated in each resistor? What is power? Power is equals to, we have discussed it, no? Power is equals to I into R. We know I, we know resistors. Then can you calculate? Okay. Then verify your calculations by adding the total voltage drops. On the series circuits, they should equal the voltage increase of the power supply. Means the voltage consumed by 3 resistors should be equals to 125. Add these 3, then definitely it is equals to 125. That cross verification should be done. Now that is done here.
అంటే
Hello.
అంటే
Someone has not muted the audio.
ఆ,
Okay. I calculate power dissipated in each resistor. Okay. So that is V1 into I1. V1 is calculated. I1 is calculated. Okay. That is done. I hope all of you got the same answer. So power, unit of the power should be watt. Is there any different answers other than these? All of you got the same answers? All of you got the same answers? All right. I have given empty space in the notes. So write down the same things in proper manner and try to solve that parallel connections where voltage will be same but current will be different. So try yourself and let me know the answers. Then we will cross verify it. Okay. So in next class, this is what the complete solution. This is the complete solution. In the next class, we will discuss the types of the network elements where we do cover active passive elements, linear and non-linear elements, and bilateral and unilateral elements. Okay. Do you have any doubts?